The Anthropocene is this geological epoch that would have started sometime in the 1940s, demarcated by a dusting of radioactive isotopes across the globe. Humans, geologically speaking, have excavated tons of rock. Just straight up mining has had a massive influence on a number of landscapes. But we've also disrupted many other natural cycles. Take, for example, the carbon cycle. Just look at the crazy amounts of carbon dioxide and methane we release. And believe it or not, this stuff shows up in the long-term records of the Earth as well. We can take ice cores and analyze gas composition, look at temperature to monitor climate change, and so on. We've also turned the nitrogen cycle completely upside down. Ever since we invented the Haber process in the beginning of the 20th century, we've been using huge amounts of energy to convert atmospheric nitrogen into ammonia, which is then used as a fertilizer. Fertilizers are incredibly important for addressing food security, but the amounts of ammonia and nitrates that we've been introducing into these systems is wildly unnatural. And they don't sit in agricultural fields, they do move out into natural areas rather easily. We've also degraded and broken apart, or fragmented, many natural habitats, displacing quite a few native species along the way. Now, some species have been driven to extinction, while others have been introduced into new areas where they may have become an invasive species. But that stuff won't necessarily show up at a geological level unless maybe future generations or extraterrestrial archaeologists are going to be studying the fossil record sometime far in the distant future. But anyway, because we need a clear geological definition, it's that dusting of radioactive isotopes that actually defines the start of the Anthropocene. Of course, in terms of climate, we're seeing global increases in temperature and other trends as well, like increased frequencies of heat waves or severe weather. Not all of this is our fault. I mean, don't get me wrong, a lot of it is our fault. But we're also coming out of a glacial period. With these cycles of glaciation, we do expect some fluctuation. Look at these charts. Carbon dioxide's up, methane's up, and remember, methane retains 84 times as much heat as carbon dioxide. Of course, it sticks around in the greenhouse gas layer for less time, but its overall contribution to the warming effect is, well, 21 times that of carbon dioxide. Still, all of these jumps are very, very concerning. We also see increases in plastic production, concrete, and black carbon. There's just a ton of stuff that's been increasing. And sure, with the growing human population, it makes sense, but it's unsustainable and largely detrimental to the planet. We can take a step back and look at these changes on a bigger scale. With these satellite views of Earth, we can also see incredible amounts of light pollution. Now, light pollution might not seem as problematic as air pollution or water pollution, but it actually has a very negative effect on behavior and life cycle for a number of different animals. Of course, anywhere you see a light bulb, there's a person. Well, maybe not in some of these massive empty parking lots that we light up for some reason, but whether there's people or not, there's concrete. And concrete not only has a huge environmental footprint just in terms of production, but once it's laid down, it's an impervious surface. It's nothing at all like soil. If we put our satellite view over to the Great Plains, you'll see a lot of roads, farms, and cities that break up what would have just been contiguous grassland from one end to the other. This is called fragmentation. And trust me, the bits of grassland that are left probably aren't very high quality. Degradation is just as important on its own, and together with fragmentation, poses incredible threats for species diversity and ecosystem function. Oh, I love this photo. At first, it looks like a rocky shoreline, but if you look more closely, you'll see that all of these rocks are actually shells. This is a beach of zebra mussels. Charming, I know, right? This invasive species has been really detrimental to a lot of aquatic systems, and they're a particularly big problem here in Minnesota. Speaking of Minnesota, you drive up north, the Iron Range. Now, Mining is probably one of the most important things we do as humans, for better or worse. Steel, aluminum, and many other metals are used in just about every part of modern life, from airplanes to xylophones. Okay, well, maybe you're not using xylophones on a day to day basis, but I was going for an A to Z effect. But what about coal? It's dirty, nasty, but economically, it's arguably more valuable than gold. The Industrial Revolution, steampunk, modern technology. Anyway, all these years later, we're still reliant on fossil fuels, although it's mostly just natural gas now. This is a bit depressing, maybe, but remember, the world population is still growing, and energy use is increasing exponentially. But 20% of the energy in the US is from renewable sources, so let's be optimistic. The glass is 1/5 full. But even clean and renewable energy sources like solar and wind, they rely on rare earth metals for some of their components. And those things aren't renewable, and their footprint isn't all that clean. So, personally, I don't really like calling solar and wind clean energy. They're just cleaner energy. They're renewabler. It's a bit of a continuum. Natural gas is much, much cleaner than coal, and wind and solar have a much, much more limited environmental footprint. But everything does have a cost. For example, solar panels use huge amounts of pretty rare earth minerals and stuff like that, things that are not renewable materials. But the energy itself, that's the renewable part. The sun won't be turning off anytime soon. Well, not for another 7 billion years at least, but don't worry, nothing will be around by then. All life on Earth will die out about 3 billion years before that. I'd recommend reading Wikipedia's The Future of Earth page for more uplifting facts like this one. Some of the elements that are going into solar panels, batteries, and other electronics are actually quite hard to obtain and rare. Take a look at copper and tellurium. Sure, while copper's pretty common, tellurium's not, at least here on Earth. Of course, lithium, which we all know, it's in pretty much every modern day battery. It's indispensable for the sustainable energy grid, but it's not very common. Now, we're projected to run out of most rare earth elements over the next several hundred years, which is one of the reasons, by the way, that asteroid mining is such a brilliant idea. But what's kind of concerning is that the common stuff isn't unlimited either. Like copper. We could run out of copper within the next 25 years, and lithium, by the way, won't be long after. But no, we won't really run out of copper. Well, there won't be a physical scarcity. It'll just be that higher quality ore will be harder to find, raising extraction costs and pushing us to recycle more. This won't be a catastrophe, but prices will definitely increase. Personally, in the short term, I'm a lot more worried about lithium stores, so within the next century. But either way, this should make you pause and kind of think about the seedy underbelly of sustainable energy. Surprisingly, very few people consider nuclear when it comes to the future of energy. Carbon emissions are nearly zero. This is better than a lot of renewable energy sources. But we do use a lot of water, and while it's very safe if done correctly, accidents are serious. Interestingly, the cost of solar and wind has come down over the past decade, though, so nuclear does seem like it's relatively more expensive now. But it's also a matter of scale. Very little land is required for a nuclear reactor, and massive amounts of energy can be obtained from a small amount of fuel. It's just something we need to consider when we want to scale up our energy grid, especially if the goal is to have, all electric vehicles by 2035 or whatever that exact target is. Now, with some renewables like solar and to a lesser extent wind, energy production is just one side of the coin. Energy storage tends to be the bigger challenge. The sun only shines during the day, and it's not windy all the time. When we generate energy, we'll use some and store some for later. Ugh, batteries. Batteries have a huge amount of rare earth metals and elements in them too, stuff that's not easy to obtain or recycle. Take cell phones, for example. When we look at the recycling rates of the different kinds of metals and other components, you can see that, sure, aluminum is readily recycled, but a lot of these rare elements aren't. And yet we just keep letting our phones break, upgrading them every year and maybe trading them in, but most of these different components just won't ever be recycled. Environmental impact is easy to see for some things, like how burning a gallon of gas in a car emits about 9 kilograms of carbon dioxide. But we should take a minute to talk about the virtual realm too, the metaverse. These aren't real places, but they're consuming vast amounts of energy. Internet data centers, along with all the gadgets that we use to access the internet, this accounts for about 4% of global greenhouse gas emissions each year. That's a lot for a virtual space, right? Believe it or not, it's about the same amount of emissions as the entire airline industry. A single Google search can power a light bulb for 17 seconds. This absolutely blows my mind. Adding it up, 1,000 searches could fuel a car for 1 kilometer. Now, when we look at stuff like this, we can start to do some calculations and go, okay, well, if we want to kind of minimize our virtual impact, our virtual environmental footprint, what can we do? There was one study that showed how if every adult in the United Kingdom sent one less thank you email, this would save over 16,000 tons of carbon each year. That's the equivalent of taking over 3,000 diesel cars off the road. And that's just one email, right? People send way too many emails. You'll send something like, "Thanks for the update," and that's all it says. And yes, messages like Facebook Messenger and WhatsApp, they're only slightly better than email. It's obviously a bit of a different system that they run through, but environmentally, there's a similar impact. Anytime we're sending lots of data, that's where there's a huge footprint. So it shouldn't be surprising to find out that video streaming is one of the worst offenders. Now, this is going to sound completely made up, but trust me, it's not. Watching half an hour of Netflix is the same as driving your car for 4 miles. Some of that power goes to the TV, a lot of that power goes to Netflix and the internet. There's a few ways you can kind of ameliorate this. For example, streaming in standard definition instead of HD can reduce CO2 costs by about 86%. Another thing is if you're on your phone, stream over Wi-Fi. It uses about half as much energy as over data, and it's also quite a bit cheaper. With the coronavirus pandemic, many classes and meetings have turned to Zoom to avoid being in person. But this is still video streaming. 1 hour of video conferencing can produce 1 kilogram of carbon dioxide. Not to mention it requires up to 12 liters of water. Water is involved in cooling a lot of these servers and computer stuff like that. But still, video conferencing can be more environmentally friendly than driving out to a meeting, unless maybe the meeting is really close to your home. But anyway, my point is that even in the virtual world, the effects are real. And circling back to the original topic of this video, here we are in the Anthropocene, this new age of human-mediated changes to the Earth. A dusting of abnormal isotopes, increased carbon dioxide all around the planet, and rocks moving from one place to another, refined, used, thrown away, all of that. Critics do argue that on this sort of geological scale of things, billions of years, the Anthropocene doesn't really show up. It's arbitrary and made up. It continues these cycles of glacial and interglacial periods at best. And I don't necessarily argue with that, but I don't agree with it either. Because when we look at the history of human life on Earth, 10,000 years ago is when we started to see agriculture appear, but even before then, we were seeing extinctions of megafauna from hunting and increasing deforestation. Most of this time, too, we're moving around, migrating, emigrating. More and more, we bring different species around with us. So things take off exponentially. There's the introduction of fossil fuels, the information age, advances in cultural exchange, and with all of these activities, greenhouse gas levels are increasing this whole time. Finally, I want to play devil's advocate and ask you about the kind of lasting impression we'll make. Again, I think the whole word, the Anthropocene, it's just kind of intended for debate because it's human-centered. It's literally anthropocentric. It's about us. And I don't like to do that, and a fair number of other scientists probably won't either. It's hard to be objective when the lens is pointed at ourselves. We're the ones under the microscope here. But it's also very important to acknowledge the effects that we've had on the environment. Whether they show up at a geological scale or not is kind of irrelevant because, well, it will eventually. Maybe it's hard to pick out now from natural stochasticity, variation, fluctuation, but we're on a trajectory for permanent global change, and we're already seeing a lot of this stuff start to happen. Think back to Principles of Geology by Charles Lyell. We talked about him back when we were talking about Darwin and other early evolutionary ideas. The same processes that shaped and eroded entire mountains will bury our landscapes too. What might the geology of the Anthropocene look like to future civilizations? When they look at these layers of rock, are they just going to be seeing a single lonely stratum of concrete, steel, and alloy? We can only guess. But also remember the principle of faunal succession and that mass extinctions are typically followed by periods of speciation. Things will change. We shouldn't be accelerating this change, nor should we be pushing it in a direction that's unnatural. But we should also feel some comfort in the fact that once we're gone, and however many species go with us, there will be open niches. There will be adaptive radiation. Things will come back. It might take a long time, but it'll happen. Life finds a way, to quote Jurassic Park. So with that, that's all I want to leave you with. I know it's a lot to take in because humans have had such wide-ranging effects on the environment. But I think one of the most important things to focus on going forward is to promote biodiversity and to maintain ecosystem integrity. The more connections we have, interactions between different components, the stronger, the more stable and resilient our natural ecosystems can be in the face of anthropogenic change.